In this video, we are going to talk about Venn diagram questions, and that will be for your BMAT part 1. And hopefully, we can do it in under 15 minutes. So I am going to break down this video into two parts. The first part, let's review Venn diagram. And then we'll be using the concept and technique we talked about in the first part to solve problems in the second part. And the problems we have will be from the actual BMAT exam. First, let's do a quick review. So I assume that you have learned about Venn diagram before, so we'll go fast here. In this particular question, we have 100 students in the school. Out of those 100 students, 60 are taking science class. And then 40 students are taking math class. And then we have 20 students. They take neither science nor math. And the question is, use the above information to determine number of students taking both subjects. So in this case, 100 students, that is the entire school, that will be represented by the big rectangle. For each circle, as you know, we will have science and math, and that will be 60 people and 40 people. Now, what about the 20 students who take neither science nor math? Well, for those students, they are represented in the yellow area. And that is the area outside of both circles. In this case, the yellow area will be 20 students. Now, let's try to look at the area of the two circles combined. Let's look at it this way. We have 100 students, and then 20 students are in the yellow area. That is the area outside of both circles. So we can conclude that the area which are two circles combined. So this area, that will be 100 total minus the yellow. 100 minus 20, we get 80. So in set terminology, we say SUM. Combining the science, the math class, we have 100 minus 20, 80 people. Okay? So that's the first way we can look at the area of S combined with M, or S union M. Next, let's take a look at the same area using a slightly different angle. So, if we look at S union M, well, if we look at S individually, we have 60 people. And if we look at M individually, just only M, we have 40 people. If we add 40 to 60, S plus M, 60 plus 40, we get 100. Now, what's wrong with this? Because in both cases, we are looking at the area of the two circles combined. We got 80 in the first approach, and we got 100 from the second approach. What's wrong here? Well, actually, the number 80 people is right, and the number 100 people is wrong. Why is it? Because if we take the S and we add it to the M directly, we are essentially double counting people in the overlap area. So these are people who take both subjects. And that is the reason why we have 80 here and we have 100 here. the difference is 20, and that is the number of people who are double counted in the second scenario when we do S plus M. Or in this case, the number of people who are double counted, those are people who take both science and math. So we conclude that S intersect M, or the number of people who take both subjects S and M, that will be 20 people. Now, you can pause here and take note, but if you don't want to take note, I'll summarize the formula we use in the next slide. So here is what we just did. M union S, the number of people who take either math or science, is the same as take number of people in math class, add it to science class, but make sure you subtract people who are double counted, and this is M intersect S, or people who are taking both subjects. Or in plain English, students taking M or S, math or science, is equal to number of students who are taking math plus number of students who are taking science, and then subtract number of students who are taking both math and science. And that is a review of Venn diagram. Now, you are ready to take this concept and apply it to solve BMAT question. So the first question we'll be looking at, that will be from 2012 exam, question 8. Now, if you want to read the question or attempt to do this question on your own, you can pause the video. And I encourage you to at least read the question. But right now, let's read it together. So in this question, a survey of households in a town show that between 75 and 80% own a dishwasher. Okay, so we have 75 and 85% for dishwasher. And then between 35% and 40% own a tumble dryer. And finally, we have less than 5% who own neither appliance. And the question asks, how many people own both appliances? Well, this question is similar to what we did before. Okay. Remember, for the math and science, they give us similar information and they ask for a number of students who are taking both subjects. But what's the difference here? Well, for this question, instead of giving you an exact number, like 75% own a dishwasher, they give you a range. Okay. So for dishwasher, I'll call it D. You have between 75% to 85%. And for tumble dryer, I'll call it T, 35 to 40. And finally, for neither, you have less than 5%, that is 0 to 5%. So, we are given information in range. And if you look at the answer choice, they are in range between 10 and 30%. So here is what we are going to do with this question. We are going to calculate a lower bound, that is the lowest number of people who own both appliances. And we are going to separately calculate an upper bound, that is the highest number of people who own both appliances. appliance. So there will be two cases, and in each cases, we will be selecting an appropriate number to be used. So case 1, lower bound. So the lower bound will be the smallest number of people who own both appliances. So I'll draw my Venn diagram with the D, the T here. So we look at the number of people who own both appliances. In this case, the overlapping yellow area. We want the lower bound, which means we want to make the yellow area as small as possible. We don't want them to overlap if it is possible. So which number should we use? Well, if we don't want the two circles to overlap, we want to minimize the overlapping area. When we pick the number for D, we should make it as small as possible. Because if only 75% as opposed to 85% have the D, the dishwasher, we are essentially minimizing number of people who have both appliances. In this case, we'll go with 75% for the D. With the same logic, we go with 35% for the tumble dryer. And finally, let's look at neither. Number of people who own neither appliance. Well, if we want to minimize the overlapping area, we'll try to make the two circles as separated as possible. So I like to imagine an invisible pair of hands trying to pull these two circles apart. And in order to pull them apart, because both circles need to be contained in this rectangular area, you need to have a lot of space outside. Okay, so let me use red. Okay, looking at the red area, that is the outside area, you need to have the space so that you can pull the circles apart to minimize the overlap. So in this case, the red area, that is the neither. Okay, we can choose between 0 and 5%. We want the red area, the neither, to be small. Let's go with 0%. Okay, so in this case, we take the formula we talked about in the earlier slide. DUT is D plus T, and you subtract the intersecting area. Okay, DUT, well, that will be 100% minus the red area. 100 minus 0, because this is 0. For D, we use 75%. For T, we use 35. Formulate a formula, and we can solve for D intersect T. And that will be 10 people. The lower bound for a number of people who own both appliances will be 10 people. Okay, so 10 people. You look at the choice. You can see right away that the only possible choice is A. So we go with A. We go with A. And that's the answer. Now, this question, we're done with it. But for the sake of practice, I'll walk you through how we calculate a lower and upper bound of 30%. And that will be case number 2. is number 2. We talk about upper bound. So for the upper bound, we want to maximize the overlapping area. A Venn diagram will look very similar, but instead of pulling the two circles apart, we want to force them to overlap as much as possible. And to do so, we will be selecting the numbers for D and T that favor us, that favor the case where we want to maximize the overlapping area. In this case, we want to make the overlapping area large. For the D, number of dryer, we will be picking 85%. For the T, we'll be picking 40%. And for the neither, that is the outside area, we want to make it large so that that area kind of forces the two circles to collide together. That's why we'll be using 5%. Okay. So we get the number, and then we crunch it in the same formula. And with a calculation, we get an upper bound of, I believe, 95, 30%. And that's it. That's the upper bound, 30% here. And the answer is A.